Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that specializes in supporting digital transformation of operations and businesses in Asia. Our guest today is Orr Dannon, CEO of Hailo Technologies. Hailo specializes in artificial intelligence processors to deliver data center class performance to edge devices. In this talk, we discuss the importance of specialized processors for enabling machine vision on the edge. We also explored ways that edge processing can lead to cost reduction and improved performance for tasks such as inspection and quality assurance. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iot1.com. Finally, if you have a business challenge and would like to discuss solutions, please email me directly at erik.walenza@iot1.com. Thank you.
Orr, thank you for joining us today.
Thank you for having me, Eric.
So let's see, before we get into the discussion, and this is really an interesting topic to me because we've been doing a lot of work in edge computing lately. I'm really interested in your background. You have, worked with the government, right? Or the Israeli military for about 10 years or so. And then you, in 2017, together, I suppose, with maybe some colleagues or people in your network, set up Hailo. What's the backstory? How did you make the leap from the military to then setting up an edge computing processor company?
That's a really good question. I mean, how are the two topics related? And the answer, they're not really related, but it does fit in eventually. I'll try to explain. So I've been with the Army for quite a long while, over a decade. And throughout the career there, I've gone through lots of areas from analog, electronics, digital, and the last couple of years, cyber and embedded. So pretty much all over. And that's what I found out that I like to do. I like to do interdisciplinary things. At some point, decided that I want to leave the big organization, all its benefits, and go found something that will be more of my own. That's where I teamed up with my co-founders, Rami, Avi, and Adar. Actually, we have quite a story there. Rami, who was the co-founder, was actually my commander in the unit I've served in the intelligence. So he brought us all together into this group, and we started thinking of what we're going to do. And the Avi, my CTO, was then with the Texas Instruments. He was the CTO of the IoT group in Texas Instruments. And he told me about this whole new big trend of AI, which I had no idea what I was talking about until that point. And it looked really fantastic. And it also seemed like back in these years, I was mostly in software. And it seemed like there's a really big paradigm shift that is coming. We tend to look at AI in terms of deep learning specifically, in terms of the applications that it enables, and this is, I guess, the most important part. But you can also think of it from how are we developing this kind of technology, and the whole approach of being data-driven, both in development and in runtime, is something that is instead of decision-driven, which is the classical way to design a computer program, and this is the classical way a processor is designed around. I mean, how to make decisions very effectively. And here it is about, both in terms of when developing models, about gathering data, and the data defines the solution that you're developing. And in runtime, flowing the data through your neural network, deep neural network. So it was pretty clear that back then it's going to be a really big paradigm shift. And it was clear that there's a huge, huge efficiency gap in processing technology. Back then, NVIDIA was already the established leader in the market, especially in the cloud. And there was a big gap in the numbers between what needed to be achieved, what theoretically can be achieved and what is actually being achieved at that point in time. So we decided that we'll explore this direction of building processors for AI specifically. And to me, it really appealed because it was clear that it is going to be a highly multidisciplinary project. I mean, it's going to be about algorithms, it's going to be about embedded software, about build systems, about chip design. So it's going to have lots of ingredients inside in the applications. They are so widespread. It's amazing to look at all the things people are doing today with deep learning, even back then. So all in all, it really appealed to me as something that has so many aspects to it. And that's what, based on my experience in the army, was a thing that I realized I like to do. And that's why we started the company. I was mentioning Rami. He actually passed away a few months after we started. It was quite a tragedy, drowned in the Mediterranean Sea. So it was another, I really liked him, naturally. And it was quite a shocking experience to begin a startup with. But we pulled through, moved on, in some senses, even with more energy to make this project work. So that's kind of the founding story behind the company.
Okay, well, I'm sorry to hear that. Yeah, but I guess every company has a founding story, and it's quite a powerful one. I was going to ask, it looks like on your LinkedIn profile you were VP of R&D, and then 10 months in you became CEO. So I guess that explains that transition there. But now you have certainly a legacy to fight for. Growing the company. I think a lot of our listeners are becoming more familiar with the concept of edge computing. And why would we need processors that are specialized for this task of doing computing on edge devices? But I think a lot of people still, it's a little bit of a vague concept. Why don't we do things in the cloud, or why can't the same processors that we use for data centers or for our laptop computers or mobile phones also work for edge devices? For you, if you can put this very simply, what would be the primary value proposition or the primary problem that you're aiming to solve here for the industry?
Okay, so basically what we are trying to achieve as a company is to bring capabilities of AI processing that are currently available at the cloud and bring them closer to the source or the sink of the data. This is the kind of the edge computing or IoT paradigm. And the thing is that when you go to the edge, you have constraints. Contrary to a data center where you have lots of electricity, lots of compute power available, you're looking at small, power constrained, cost constrained, area constrained devices. You need to make really efficient processor. And the more efficient you make them, the more capabilities or feature that you can bring to the end device. And this has to be a different type of processor. This is their optimization goal. Now, moreover, the thing that has happened in recent years, especially around sensors and especially around vision sensors, is that the main requirement from a processor that processes these signals is to do AI. Everything in visual processing in recent years has moved to AI or deep learning. It's the same, or at least for our purpose, it's the same, to AI-based methods. And the compute requirement in terms of capacity, just to give numbers, to process a video stream at high resolution, not even that high, but a significant resolution, let's say 1 megapixel at real time, typical applications are about 10 trillion operations per second, 10 teraops. So these are crazy numbers if you think about how processors are designed with the gigahertz range, 3 orders of magnitude more. And the way to overcome this is to design computer architectures which are specifically aiming to do this type of computations, AI computations, efficiently. It is as if we imagine that we've been doing computers all wrong for decades, and now we'll make them better, 2 orders of magnitude better. Maybe tomorrow, maybe not, but for now, it's not the case. The case is that we want to gain this increase in efficiency by being domain specific. So on one hand, we're narrowing the scope to AI, And on the other hand, we want, of course, to leave as much room for flexibility as possible, since AI on its own is a very fast-moving field. So bottom line, we need processors which are relying on efficient architectures to do AI at the edge.
Gotcha. So it's a kind of a case of specializing to get superior performance out of technology that to some extent already exists. If I look at the industries that you're serving, it's automotive, industry 4.0, smart cities, smart retail, smart home. And then if I look at kind of the products that you have around this, so maybe you have a set of products, but under automotive, you have ADAS, electronic control units, and front-facing cameras. And then for the others, you have an edge AI box and an intelligent camera. So do you have to, is it a case of customizing the processor for each of these different specific use cases? Is that how you maximize? Or is it primarily the same processor behind all of these use cases, but you're just putting them in different form factors for these different situations?
Yeah, I think this is one of the actually most reassuring aspects of the business, that we have one product with some variants around it, but mainly one product called the Hailo 8. It's a first generation processor. And we actually found out that customers throughout all these industries that you've mentioned, and actually much more than that, are interested in the same core technology. And of course, you need to do some specialization, some customization, whether it's a tweaking of the hardware or the software, but eventually based on the same product, you're able to serve a wide variety of verticals. Fundamental reason why this is possible is that they're all doing, at the end of the day, they're doing similar things. Let's put it this way. The disruption that is coming from the same direction, and that is around their video processing capabilities. If the previous wave of revolution in IoT, I think, was connectivity, and this was what defined the IoT or edge computing in general, AI is the next defining feature. And specifically, in all these verticals that you've mentioned, we're talking about processing video in real time and using similar tools throughout all these verticals. So the data sets, they vary, and the exact implementation details vary, but they, as seen in reality from the customers that are coming to work with our product, is that they're all using the same core technology.
So you're emphasizing machine vision here, and I would classify machine vision as one of the top three kind of clusters of use cases. I mean, you could use it for autonomous driving, you can use it for facial recognition for pigs, use it for quality detection on a production line. So there's a lot of machine vision use cases. Is this the primary cluster of use cases that you're focused on, is processing data from cameras, or do you also address other edge computing scenarios where you might have maybe not as heavy data from a single source, but data from thousands of sensors, for example, in an industrial environment that you need to process?
The mission that we set out is to serve the most pressing need of the industry, and it is by far vision processing. Since the amount of data that you're trying to crunch, I mean, there are a few billions of sensors that are being deployed each year in the world outside mobile phones. So together with mobile phones, it's about double the number. And they're creating tons of data. And this means tons of processing that needs to be done in order to make some sense and some use of the data. So although we do have the ability and the customers that are mixing signal types, I would say that the main strength is around vision or vision-like signals, where the amount of processing that is required is quite vast.
Makes sense. And I guess if you can process vision data, you can also process a temperature sensor, right? So that's not a significantly challenging process at that point. How much customization is needed? So let's say on the one hand, you have an automotive OEM, and on the other hand, you have a company that's building cameras for smart cities. Are you working with each of these companies to design customized solutions to meet specific needs? Or is it basically, okay, we have our product, we give you the toolkit, you can customize it as needed, and you kind of are selling the product without let's say, an R&D project built around it? To what extent are you also providing the service of customizing and supporting project development?
Okay, so it's more of the latter. We generally we have one main product line, and around that product, of course, we provide lots of support. We're not a service company, and we do not provide AI engineering services. But what we do have is we have accumulated quite a wide experience of how people are deploying AI. So we will never know better than our customer the data that customer is using for its specific use case, but we will know what is or can advise on what is the best way to deploy it. And that we find many customers find very useful. I will say that there is one exception to the general statement I've given, and that you actually gave it in your example, and that is automotive. We have gone through specifically additional extensions which are relevant to the automotive industry. First, there are two main things that are relevant. One is quality, both in processes and mainly in the physical quality of the device. So one of the value propositions that we bring to the table is very low power consumption. This allows us to work at very high ambient temperatures, which is really helpful in the automotive industry. The device can operate up to 105 degrees Celsius. And also functional safety mechanisms. There's a big concern in mission critical systems. What is the rate of failures of your device? It is something that is actually standardized to the ISO 26262. Since we understand the tremendous potential of the automotive industry for AI applications, we have baked into the architecture safety mechanisms that enable you to detect these errors that might happen randomly on the hardware. Usually the naive way of being able to detect errors and then, of course, act accordingly is to just replicate all the computations. So just do everything twice. Now, if you're a brakes system, that's fine. You need to do 10 calculations and then you do them again, no problem. But if we are going back to the number that I gave about teras and teras of operations, then it doesn't make sense to duplicate them. But you can make use of some of the fundamental properties of neural networks. And that's what we have done to dramatically reduce the overhead that you need to make sure that you have no mistakes in your calculations. So this is something specific that we did for automotive industry.
Okay, clear. And primarily because it's a mission critical activity, so heavy processing needs to be done right the first time, basically. You have a couple products here. So I understand that the Hailo 8 AI processor is the primary one. Then you also have the M2 acceleration module, the mini PCLE acceleration module, the evaluation board, and the data flow compiler. What are the roles of the acceleration modules? I guess the evaluation, maybe the evaluation board and the compiler. Are these support capabilities for R&D, or the accelerator is maybe higher power capability?
So basically, the modules are based on the same device. What we found out as we started working with customers is that many of them have similar use case of existing compute platforms, which have extension slots of PCIe, whether it's M.2 or mini PCIe. M.2 is actually the evolution of mini PCIe. We are providing Hailo branded modules that incorporate our device on these modules, and this really accelerates time to market for customers since they don't need to go through hardware cycle design. They just plug it in. This could be a slot that was originally planned for a hard disk drive or a Wi-Fi module or GSM module. So pure platforms tend to have these extension slots. For a customer that wants to add AI to its product, is something that can happen really fast and save you at least the hardware design cycle. Of course, you still need to design your software, but in terms of hardware, you get something that is almost out of the box. So this we found very helpful and very popular with customers.
Gotcha. Okay, great. So now I think we have a good understanding of the use case, the industries you're serving, and the products here. Let's get a bit more into the tech stack. So you mentioned that for you, this is a very interesting problem to solve because it integrates a lot of different technologies. How do you look at the tech stack? And then which elements of the tech stack are you building internally? And which elements are you integrating that are basically somehow on the market, but you're integrating them into the full solution?
The core technology that we are building is the neural network processing core. This is our own proprietary architectural design, both in terms of hardware and software. And this is actually our core differentiation if you look across the market. In this part of the stack, we are providing, it's a really interesting problem because the way we built our device is actually by, instead of looking at the problem of calculating a graph of a neural network sequentially, node by node, what we are doing is doing it in parallel. We are distributing the compute along the core. We have very small virtual core that we are building dynamically in runtime. And these little cores, each and every one of them is in charge of different part of the neural network. So this actually means that calculations propagate through the network as they are available. And this is a very different way to describe a compute problem than sequentially going over all the calculations that you need to do and doing them one by one on a very powerful and parallelized core, like a CPU or a GPU. Now, and this goes back to what I said about paradigm shift. This paradigm of doing things that are spatially distributed, kind of, can even think of some sort of an analogy to serverless or Lambda functions deployment. This only works well or mainly works well with neural networks. It doesn't work well with general purpose code, like an operating system or something of that sort. And this requires a really extensive software stack that abstracts all this complexity from a user who just wants to describe a graph in, let's say, a popular framework like TensorFlow or PyTorch, which people use mostly to describe neural networks, and have all the translation being done automatically to the primitive that our hardware implements. These are core competency and where we invest a very significant part of our efforts, both in terms of hardware design and software design. And of course, the machine learning competency that defines what needs to be done in hardware and software. And this is about one aspect of interdisciplinarity, which we are doing, working very hard on. It was actually, for me, as a CEO, very important to find people that are well-versed in all these fields and are not afraid to jump in between the algorithmic part, the software part, the hardware implementation part, and have a very, I would say, well-balanced architecture. Other than that, of course, from technology stack point of view, we are building a full product. So we have all the usual aspects of embedded programming. Of course, chip design is a big, or embedded computing system. Chip design is a big proficiency that we are holding. And all the embedded firmware drivers, computer vision, all the integrations that need to occur for a full-fledged product in a well-designed system that we are also doing internally. We're not reinventing the wheel. We're using technologies that are available on the shelf, but building them into a full system is something that we do internally.
Gotcha. Yeah, you have it very well visualized on your website, the kind of innovative approach that you have here. So if you look at the neural network graph, you're moving from layer 1, layer 2, layer 3, layer 4, et cetera. And then you actually, at least as I understand it, you have physically on the processor different areas that are processing each of these layers. Two questions here. As we look from layer 1, 2, 3, 4, et cetera, what does each layer include? Is the first layer saying we understand lines, and the second is we understand connections between lines, and then subconfigurations, and et cetera? Or what would be the features that you're moving through? And then maybe second question, a bit different, is where did this concept come through? Was this a clear concept that maybe your CTO had in mind that he wanted to test out, or was this just a bunch of experimentation and you eventually arrived upon this as the best solution to the problem? But maybe first question is just, can you explain a bit, what does each layer actually indicate?
You described very well the way the hardware is structured. It's actually a reflection of the way neural networks are described in the abstract programming frameworks like TensorFlow and PyTorch. When you look at the description of a neural network, it's usually composed of layers. Each layer contains or is supposed to represent a deeper representation of our understanding of the image. So the first layer, the receptive field, is all the pixels of the image. And this let's think of the pixels as the first layer. And as we move on to the second, third, and fourth layer, we are aggregating combinations of pixels and patterns together to create a more and more complex representation of the image, trying to conceptually transition from raw data into insights on the other side of the pipeline. So this is just how neural networks operate. This is not related to our architecture. What's nice about our architecture is that it reflects this structure in the hardware. And this is what makes it so efficient. This is also, by the way, actually quite the way we got there. I mean, when we started, we didn't really have an idea how to do it. We did realize that there's a big potential to improve but we didn't know exactly because it's easy to design a processor that can run one task very efficiently. I mean, it's not trivial, but you can relatively easily pull it off. When you start looking at this as a programmable device and think on one hand, having the capacity and the efficiency, and on the other hand, having the flexibility to be able to run different workloads. And also, I think we've been working since 2017. 2017, up until now, how many things have happened in the world of AI? How fast is this world evolve? So you need to also think in the architecture to keep things flexible enough in terms of what the future holds and how will this field evolve and what does it mean that I will need to support in my architecture, once again, while being efficient and providing a high capacity. We did, in the first year of our existence, about 4 iterations on the architecture. We had we thought about a concept to a processor, we implemented it, we started trying to program it, understood what are the issues, what are the problems, what are the bottlenecks, threw everything aside and did 3 more of those until we reached a point where we said, okay, this looks good. Now let's make a product out of it. And that's what we said. So it took us about a year to get to that concept. And then we started running towards a product.
To use simulation, basically, to, as you move through this process to determine when you're
well, or do you actually have to build and test this in the physical world?
Yeah, so I'm a big believer in doing end-to-end cycles. So we actually use the FPGA technology, which some of the listeners might be familiar with, to do these cycles. It was very helpful. I mean, it doesn't give you the full picture of a whole device, but what it does give, it gives the software people and a very powerful tool to do, instead of simulation, which tend to be very lengthy and very limited in what they describe, because you're only able to sample a very small subset of use cases. My belief is actually the main thing that will help you understand if what you're doing is right or wrong is to run as much software as possible on that. And that can be more easily done with something that might be less representing in terms of hardware, but more representing in terms of the ability to scale software on it. So we started actually by using FPGAs and afterwards moving into more hardware-oriented or ASIC-oriented approaches.
Got you. When did you first build a physical chip?
So we had a prototype device that we sampled, I think, at the beginning of 2019, somewhere back then. It's recently at the end of last year, we have a production device, which we started sampling late last year, or more accurately early this year, to a very large amount of customers.
Are you able to say who's producing this with you, or is that confidential?
One of the leading foundries.
Okay, gotcha. Just I'm curious, there's been quite a significant disruption to the supply chain in the past, especially around chips for automotive. Is this impacting you, or I guess a lot of this is impacting more the older generation of chips? But is this a disruption to your business, or are you still able to work through this fairly well?
We have been able to work through this really well or not. It's a matter of level of expectation. Yeah, I mean, as you mentioned, there've been specifically on the older process nodes, there's been a really big shortage. I think actively teaching everybody a lesson about controlling your supply chain and not having, the cost of over-optimization. I hear that many people are reconsidering their just-in-time policies, meaning, if you're a supplier, bring me the components only when I need them. The risk, of course, is if the supplier cannot, if the supplier doesn't have a supply at that point, you're stuck without being able to assemble your product. So on one hand, it's more efficient on capital. On the other hand, it is much more risky in your ability to operate. So I think everybody will come with a bit of a different approach as we walk out of this current stretch in the supply chain. However, we've been relatively lucky. We've managed to pull through this. Hopefully, this will stay this way.
Yeah, sure. Well, we'll get through this eventually, I guess, as an industry, at least this current challenge. So there's probably a number of different areas of the tech stack that we should be touching on here, but there's one in particular that I think is significant concern for industries like automotive, also a lot of manufacturers, which is concern of security of edge devices. So this at least appears to be one of the bottlenecks to wider adoption in the short term. Is that a topic that you're addressing, or is it basically a separate set of companies that are working on the challenges related to cybersecurity, and you're integrating best practices as you build your solution?
Our main focus was on AI. In terms of standard processing, we are following best practices and taking the established solutions, which I'm a strong believer in. One of the aspects in which we encounter cybersecurity is that for some customers, doing edge computing is actually a motivation that in some senses comes either from security or privacy concerns. So actually keeping data away from a centralized database is something that they find structurally better instead of doing it. Doing it at the edge instead of doing it in a centralized location where all the sensitive data is being kept, and being able to process on the fly at the edge is something that enables you not to save the data at all, even not on the edge. So this is something that it doesn't directly mitigate cyber or privacy risks, but it reduces the attack surface or the data that can be compromised by these kind of risks.
Yeah, well, absolutely. Not transporting the data also, reduces at least part of the risk landscape. No, that's a good point. Actually, a lot of, I don't know what your experience here, but a lot of manufacturers, they do also quite hesitant about moving to the cloud for any type of critical solution. So edge computing could be a good solution in those situations. Do you have one or two, I guess we wouldn't call them projects here, but maybe key accounts? You don't have to mention the name of the company, but key accounts that you could discuss, what you've built with them and how this is being deployed in the world today?
Okay, so one major thing that we see is the push of video analytics. And here there's a variety of players that is working with us on this. This is something that is being addressed both by solution providers, vertical integrators, ODMs that are building either camera or aggregation points, what people now like to call edge AI boxes, that are doing analytics. So one thing that we mainly see that people are struggling with is processing in real time in reasonable quality. In many cases, what we find is either people that are being constrained by, you can come to it from two directions. Either you say, okay, I'm going to make a reasonable edge solution, meaning let's take a ruggedized PC, for example, that aggregates, 8 feeds from a camera. There's multiple projects like this. And okay, either I'm going to make something that is reasonable to handle, so it has to be fanless. So it means it consumes less than, 15, 20 watts. If you want to detect events that you're seeing on your cameras, and it has to work with at least near real-time performance, or at least 20, 30 frames per second, otherwise just be missing out events. And combining all these constraints together brings you in quite tight envelope. And what we're seeing from customers is they're struggling. So either they go to obvious solution, which is adding NVIDIA-style GPU to the solution. This immediately takes you to completely different form factor, price point, power consumption, deployment scenario. Or you're taking something that is available off the shelf. They're often from mainly Intel, some from Google today. However, the problem there is the limited performance. You can't get to real time or even close to that. You can't use, say, standard neural networks. You have to use very reduced mobile versions, which are of very low accuracy. The result of that is that you're bringing low value to the customer because your misdetects are very high and you're giving false alarms. So bottom line, it's limited. So this is typical scenarios that we see in the video analytics, and they span across all use cases that people use for these boxes. So I would say the main ones that we see are security, surveillance, retail analytics, access control, smart city, which is some sort of a combination of all the below. And they're all facing the same challenges and looking for solutions that can bridge the gap between high performance, reasonable cost, reasonable form factor, and reasonable power consumption.
Got you. And you have under your industries kind of two major, maybe we could call these form factors. One is the Edge AI box, the other is intelligent camera. Is the primary difference here that the intelligent camera is a single sensor device that is then has embedded compute to process the information coming off that device, and the Edge AI box is taking in inputs from multiple sensors and kind of doing sensor fusion to process a larger data set? Is that how we look at these, or is there a different way that these are differentiated?
Actually, the definition, this is a common architectural dilemma that we see across industries. Do you want to process directly at the sensor, or do you want to do it at the aggregation point? And there are pros and cons to each. Depends on, for instance, if you already have established sensor suite, whether it's deployment, let's say in the building, or whether it's on your robot, you don't want to touch the cameras. So this could be a reason why you want to do things at the aggregation point. On the other hand, some cases you say, okay, we have a customer that is doing smart cities and putting sensors on poles, on high poles, doing all kind of monitoring and violence detection and things like this. So in that case, it's a camera. The aggregation point is at the cloud, but they don't want to rely on connectivity to the cloud because this will significantly make the system more complex and also mean that they will have to spend their recurring expenses on processing in the cloud. So they want to close the system in one sensor. And that is a motivation to go into sensor adjacent processing. So we see both deployment options. I think that the aggregation point is easier for most customers. By the way, the same applies also to cars, which if you think about it is exactly the same architecture. And I think for many customers, it's easier today as a first step to incorporate it into the aggregation point. But I do think that in a year or two from now, we'll see much more smart being put into the sensor themselves.
I guess it's also a question of, in order to achieve the desired insight, how many different sensors do you need data from? So is it sufficient to gather? Is that a reasonable way to think about this? If you need data from multiple inputs, then you need to use something like an aggregator, a box. But if you can achieve the results from like one kind of integrated sensor, or I guess this could be a device that might have a few sensors that are also kind of integrated on the same hardware, then that would be a solution. But is that also kind of a way to think about it, of what are the diversity of inputs that are required to achieve the desired insight?
Yeah, you can look at it from a system integration perspective. Do you want to when you fuse the data, do you want to fuse it at the raw level? This is naturally, obviously contains the most information. However, this is the most complex integration to do. You might want to be talking in a higher level of abstraction, saying each sensor with its own peculiarities, angle of view, lighting, or maybe it's even from different vendors, just provides, let's say, a standardized object list. And then you fuse the data and say, if 3 cameras saw the same thing, then the objective is there. If only one of the 3 saw it, it's probably a false alarm. And this is actually a choice that has to be done by the system engineer on, do you prefer the simplicity of the integration at the expense of making the individual components more complex? Or you say, okay, I want to concentrate the complexity at one point, have everything there. I will have a relatively complex integration, but first it will be at one point, and second, I will have all the information. So it's really use case dependent.
Understood. Okay, so you might have a situation where you prefer to have multiple sensors that all say, object detected, object detected, object detected, object detected, and all they're just reporting that there is an object that has been detected, or there's a cat that has been detected, and then the central aggregator just knows that 4 sensors have all detected an object, and it can make a decision based on that, as opposed to moving all the raw data to that aggregator and running the process there.
Yep.
Okay, great. Let's talk a little bit about the future. This is a really dynamic area of innovation right now. Of course, for Hailo, but also just across the industry. What do you see as the big innovation levers or the areas that we should be paying attention to over, let's say, the next 5 years as this market develops?
First of all, what we're already starting to see that the expertise of deep learning is proliferating from the cloud players and the really sophisticated full tech stack companies into everybody who's making electronics. And this is one trend that I think that the democratization and proliferation of deep learning capabilities will bring. We're already starting to see it coming, tons of innovation in product value. All kind of different products that we use in our day-to-day life or throughout the industry that are being reimagined using AI. And this is not only being done by the Googles and Microsofts of the world. So this is one thing that I think we're going to happen. I think we're going to see, we already also starting to see signs of that, cloud players much more invested in edge computing. I think everybody today understands that, especially with this field of edge AI, and especially for vision, it's not practical to do things in the cloud. I think we'll see more involvement of cloud players at the edge. So it will be interesting who will prevail eventually, the typical vendors for the edge, or whether the cloud full suite of offering will be include management, and you've touched upon security and provisioning will be more appealing to customers. There's another interesting trend to watch.
Yeah, there's been a couple companies that I've talked to that are quite interested in the prospect of 5G leading to a kind of localized server. So let's say you have a 5G hub that services a large refinery or a neighborhood in a city, maybe a half a kilometer radius, and you kind of aggregate data and then process it. So it's kind of, you could say an edge cloud to some extent. Do you see this as being a kind of an interesting architecture, or is it a bit too early to see if this becomes widely adopted?
I think it's a bit too early, though people are moving in this direction. Whether the market will accept it or not, this is harder to say, because it does require to tailor all the solution end to end. And this has always been the challenge of adding value from the telco perspective, providing full application, not just, if it will remain just as a floating compute resource, I don't think it will be very successful. But if it will integrate well with use cases like you've mentioned, this could be a real value proposition.
Maybe on this point, last question is, we talk about the Internet of Things, but I think the reality is that in many cases, you don't have an internet, really, right? You have a lot of relatively isolated devices that are collaborating with a few other devices, which, does the job actually quite fine in many cases. But I guess if we look at smart cities, for example, it's going to be more important or increasingly important to have thousands of devices that are really coordinating in some way with each other. What do you see as being maybe the status of this? Just from a technical, there's a whole set of kind of business and legal and privacy related challenges, but just from a technical perspective, what do you see as far as the status today? And then, do you feel like this is an important kind of area to develop, or do you feel like we can kind of get the job done and solve most practical problems without this system of systems, let's say, level integration?
The system of systems is an absolutely crucial component in enabling this whole ecosystem. And I think the right balance of what's being done at each system and how they coordinate or consolidate into something that that a customer can work with or an operator can work with is crucial. I don't think we've nailed it down yet, but I think we're going that way. And as an industry, we have to solve it if we want to make this whole new set of concepts like building management and city management and smart access control. If you want to make them reality, it has to happen. This service level, which aggregates and coordinates all these smaller system components. Because I don't believe in standalone systems.
Yeah, great. Well, lots of work to do here. We'll all be busy for the next decade at least. Is there anything that we haven't covered today that's it's important for everybody to know?
No, I think we've gone through it all. Thank you very much, Eric.
Yeah, well, thank you. Just last question then. If one of our listeners is interested in learning more about your solutions, what's the best way for them to get in touch with the company?
So you're more than welcome. Just come to our website, www.hailo.ai. We have all the information there, and you can contact us through there. We'll be happy to help.
Great. Thank you, Orr. Appreciate your time.
Thank you, Eric.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.